Okay, today we're going to have a look at a motion with resistance question from the 2020 extension 2 HSC. So we're told that a particle starts from rest and falls through a resisting medium so that its acceleration is in meters per second is modelled by this equation. We're told that k is 0.01 and we want to find the velocity after 5 seconds. Now we want in our answer velocity and we've got time. So we're going to replace this with dv dt is equal to 10 outside of 1 minus. Now k is 0.01, so 0.01 v squared. Now to integrate this, it's in terms of v, so we're going to have to flip it upside down and find dv dt is 1 over, I might leave the 1 on 10 outside of here, 1 over 1 minus 0.01 v squared. Okay, now we're thinking, okay, how can I integrate this? It's not a tan inverse because you need a plus here and a v on the top. It's not an ln because you'd need a v on the top as well. So I reckon it's going to be partial fractions. That's our other thing that we can use. So time is going to be 1 on 10 times the integral. On the bottom we're going to have 1 plus 0.01. This is a difference of 2 squares we can see. And it's going to be 1, that's a v there, 1 minus 0.01 v. Now using our cover-up method, we might just want to quickly, we've got to think, what do I have to make this be equal to get zeros? So I might just quickly 1 plus, oh, what's going on there? 1 plus 0.01 v equals 0. So minus, so we've got 1 over 0.01. So we're going to have to set it to be 100. So 100 is our magic number that we're dealing with here. So first of all, we want to set it to be minus 100 down for this one. So 1 over is 1 minus 0.01 times by 100. Oh. That gets me 1 on 2. And then over here, we're going to have to make it positive 100. So this is going to be 1 over 1 plus 0.01 times 100 is 1 on 2 again. Okay, so we're thinking, okay, this is, we might take the 1 on 2 out and make this 1 on 20, the integral of 1 over 1 plus 0.01 v plus 1 over 1 minus 0.01 v. Now in an ideal world, we want 0.01 to be on both the top of both of these. So we want 0.01 on the top. So we do need to put out the front of this integral 1 over 0.01. Now 1 over 0.01 times by 1 over 20 is 5. So this is 5 ln outside of big brackets ln of 1 plus 0.01 v minus, that minus comes from here, ln of 1 minus 0.01 v plus c, and that's equal to time. Okay, we probably want to find now my we want to find that constant c, so we need to know, well, it's initially at rest, so velocity is 0, time is 0. So 0 is equal to 5 outside of, we might combine these logarithms before we do this actually. So t is equal to 5 ln of 1 plus 0.01 v on 1 minus 0.01 v plus c. Now we know that when time is 0, velocity is 0, and we probably just can see, obviously, that c is going to be 0. Again, if we put 0 here, it's going to be ln of 1 over 1, and ln of 1 is 0. So therefore, my equation is t is equal to 5 ln of 1 plus 0.01 v on 1 minus 0.01 v. And let's think, what do we want? We want to know the velocity after 5 seconds. So we do need to make velocity the subject of this. Let's have a go at this. So we divide the 5 over, let's raise it to the power of e. So 1 plus 0.01v over 1 minus 0.01v is equal to e to the t on 5. And we want to make velocity the subject. So 1 plus 0.01v is equal to e to the t on 5 minus 0.01v e to the t on 5. So let's plus everything over. We might minus some stuff. Let's take out a factor of v. So it's going to be 0.01 minus e to the, or plus e to the t on 5, if we plus it to the other side, is equal to e to the t on 5 minus 1. Okay, so that means my velocity equation is e to the t on 5 minus 1 over, oh, I've forgotten a 0.01, it's my fault. There should be a 0.01 right there, because that's 0.01 has come and we've plussed it over to there. So 0.01 plus 0.01 e to the t on 5, and we want to know the velocity when t is 5. I'm just going to type that into my calculator. So it's going to be e to the power of, well, 5 on 5 is 1, so e to the 1 minus 1 over 0.01 plus 0.01 times by e, and we get 46.21 meters per second. And that's our answer. Thank you.